So my name is Thomas. I'm PyTorch Lightning tech lead. I've been working on the project for 1.5 years now. So I guess people could maybe introduce themselves on the chat to see that everything works properly. Okay, let's see if we get anyone to share something. Oh, cool. Okay, awesome. I'm getting the first people to interact. Hi everyone. Okay, we have someone from India here. Awesome, cool. Okay, as some people have might seen today, so we are going to do a PyTorch Lightning deep dive. So my goal for today is try to share some best practices around how I approach software development, but also in a broader way, how I usually go to learn something new, right? So today I'm going to try to convey how I've learned Lightning when I started and what was the thing I did to actually get to know the framework. So let's maybe wait a little bit. I see we have 11 people here. Hey Aniket, hi. Awesome. We have Aniket who is a contributor to PyTorch Lightning. Cool. So yeah, okay, I guess I might be able to start. Okay, cool. So let's start by how I usually approach discovering a framework, right? So what I will usually do is I will just start. So let's see, Google PyTorch Lightning, quickly go on the framework, and I will also open the documentation next to the framework, right? So here what I will usually go and do is check the contributors and check if the project is still active. So I will just try to filter maybe the last month and see that a lot of work is being done. I can see that there were like a lot of commits, so PRs which has been merged, and there's definitely a lot of activity here between Carlos and Awolchi. Cool. So I guess the next step for me will be to try to understand the structure of the framework. So usually, hey, hi, someone joined. So what I will do is clone the repo, right? So here I have already the repo clone, and I also created like this small demo. I will go through that slightly after, right? So I think the first thing when you want to, let's say, understand a new tool potentially, and like maybe at some point become a contributor, is to look at the structure of the framework, right? So I'm going to quickly go through the structure of the framework for people who have never done it, and I think that will give like a good understanding of how the framework has been built out, right? So when you open Lightning for the first time, you will see a couple of names you might have never heard about, which is entirely fine. We're going to quickly try to demystify some of this part, right? So the first thing you see is accelerators, right? So as someone who doesn't necessarily know the framework, I can just click on it, and here I see CPU, GPU, APU, TPU. So I will get the idea that whatever is inside of this folder is responsible for handling the hardware, right? I could actually maybe even, yeah, so let's not dive into the code right now. Let's just keep it high level on how things are organized. So here I see the next one is callbacks, right? So callback can be an advanced concept for some users, especially when you're new to Lightning, but I guess the idea which is usually around the callback is it's something which can be called at a given time, and you can put some of your code inside, right? So it's a self-encapsulated program, which is not necessarily research, which is not necessarily engineering, it's something else, right? So that's something which is really inspired, I guess, from the web world, where you create callbacks and hooks to just react on some events, right? And then here I can see the folder core. So core, as I will imagine, like really contains the key elements of the API. So here, if I'm new to Lightning, I will actually see a couple of things here. So data module, Lightning module. So maybe one thing actually to do we have new people new to Lightning here on the in the group? Like, can people actually answer on Slack if they have if they are new to Lightning? Oh, cool, awesome. Okay, so I'm going to really start by maybe the the API, right? Because I guess when you are new to a project, you usually start by just looking at the API, right? So here, let's go quickly through what the README tells us, right? So it tells us that the first thing you have to do to get started with Lightning is install the package. So that's quite simple. There's other options if people want, but like that's really the recommended way. The next part is you import PyTorch Lightning, and you have a couple of building blocks, right? So the two main components are the Lightning module and the Lightning trainer, right? So that's like the two first entry points when you discover the framework. The Lightning module is a system which encapsulates all your research code, right? So when you have used PyTorch a little bit in the past, you might have created NN modules and then optimizers and all this basically code you need to train your models. But with Lightning, the idea is the code is organized under some functions, some hooks you can override, and every Lightning module will look the same, right? So if you go into someone else's code base, you will just find out that the code you're actually looking for is implemented inside of the Lightning module, and that makes it extremely easy to discover. That's what I do all the time. I'll put like a new repo, and if they use Lightning, I go and check the Lightning module, and very quickly I know what they're doing, right? So here are some best practices around the Lightning module. So you create your NN modules in the init method. Inside of your training steps, that's like the meat of the training, right? So like this training step will be called when the training loop is being executed. And here the idea is you receive a batch, you do some operation for your model, and you just return the loss. Optionally, you can also log anything you want, right? So you could log, let's say, the loss, but you could also log some metrics. And then the last hook you need to implement is configure optimizers, where you will create an optimizer by providing the parameters of your Lightning modules, right? So the parameters of your model. Once your model has been implemented, you can create your model, create your trainer. So the trainer takes a long list of arguments, but here for sanity checking, we don't provide any. And you just call fit with your model and with your data module, with your data loader. So very straightforward, very simple API. So the first thing we are exposed to are the Lightning module and the trainer. And I will show you how, when I started Lightning, I basically took that code and then tried to understand how this thing works out, right? So let me go back to this part. So here I see core, I might see Lightning. Okay, so I will see, oh, the Lightning module actually lives in this file, right? So that's actually the thing I'm importing when I'm implementing my model, right? And here I see also data module, which is also another core component, which is used to encapsulate the data loading part, so like all the data loaders, in the same way as the Lightning module encapsulates the NN module logic, right? So then I will see, okay, so I have, actually delete that. So here I see distributed, so some logic here for distribution. So I'm like, okay, Lightning supports out of the box distributed training. I can see it here, for example. If I wanted to train on 8 GPUs, I can just do GPUs equal 8, and now I will be training on 8 GPUs. So maybe some logic might be here, but I can see only one file, so might not be there, right? Then here I can see light. So that's intriguing, right? Because it seems that there's this new feature inside of Lightning which might actually bring something, so maybe let's keep that for later, but we might come back to that. Loggers, so here I can see that Lightning supports a couple of loggers, right? So I think here the names make it very explicit. It supports Comet, CSV, MLflow, Neptune, TensorBoard, TestTube, and 1DB, right? So here, without even going to within the doc or going anywhere, I can already see that Lightning supports multiple options here for me to log anything, right? Then the next folder is loops, right? So I can see here, okay, so I see batch, data loader, epoch optimization, a fit loop, and a base loop, right? So I'm like, okay, I have the impression that the Lightning team created an abstraction around the concept of a loop, right? And I might think that it's actually within the base class, right? So here I might actually, yes, okay, so here I can see there is a loop interface, which is used to manipulate and implement the optimization. So that's something we might come back to a bit later in that live. Good to know there is something here. And I can actually see that multiple loops have been implemented. So I can see here a fit loop. I can see like a manual optimizer loop, evaluation, prediction, training epoch loop, data loader loop, prediction loop, batch loop, right? So here I don't necessarily know how the code has been implemented, but I already have the intuition from how the code is organized, so like the namespace of the files, that there is all the loops within Lightning have been implemented under this interface, right? So it means the code has been organized here and it's easy to look through. So we might investigate that a bit deeper, but what I would like to convey to the viewers is usually that's what I go, like when I take a framework, like just looking at the folder names and the file names usually give already a lot of information on what's available within the framework, right? Then here we'll see metric. Okay, actually that's something I can delete. Okay, let's keep it for doesn't matter. Overwrites. So here I can see there's maybe a couple of patching we are doing, right? So I can see data parallel, distributed, fair scale, which is a specific framework. So I can see here maybe there is some things that Lightning does to make it work with some distributed logic. Here I can see plugins. So this one seems to actually contain quite a lot of logic. So I can see environment, IO, precision, training type, right? So that seems to be, so actually let's check one of those. Okay, cool. So here I can see, for example, that by just quickly looking at the DDP plugin, it's actually deprecated, right? So it means this code here is just a way to reroute for previous versions, right? Because users might have been using the DDP plugin, and now I can see that the new plugin or the new way to do things actually through strategies, right? So I don't really know yet what's a DDP plugin, but I already know that all this code here seems to be a rerouting thing, like it's not active anymore, right? Here I can see precision. Okay, so here the code seems live, it's actually implemented, cool. So here maybe let's quickly look a bit deeper into what those things are, right? So here in environments, I can see Bagua, Cluster, Kubeflow, Lightning, LSF, Slurm, Torch Elastic, right? So if I Google those things around, for example, if I check, let's say, Torch Elastic, let's see what I get. Okay, I'm going to get that, okay, it has been moved and upstream to TorchX, so let's see if I can find it easily. And if people have specific questions, please ask in the chat so I can also react on that. Okay, cool. So let's look for Torch. I mean, I know what I'm looking for, so that will make things, yeah, I mean, almost, I guess. Yeah, okay, so I know, for example, there's this Torch distributed launcher, which is used in this following way, right? When you want to launch distributed training, so I guess like maybe this environment is to actually pick up the environment variable that this launcher is going to provide, right? So if I do make this relation between the Torch Elastic environment, maybe I might have also a good idea on what are the other files doing, right? So here I can see Slurm environment. Slurm is also like a launcher for distributed training. So I can see that inside of this one, for example, the processes are created externally on Slurm, which is true, right? And also that it's going to extract like the main address, the master port, is also going to extract, let's say, the word size, so how many GPUs are being utilized for the training, the rank of that specific process, the local rank, so that's when you have multiple nodes, and the node rank, right? So here I can understand already quickly that all these environments are really around managing the environment variables that some external launchers might provide, right? And here I can see that maybe LSF, which is another cluster manager actually relies on maybe different environment variables, right? So here I can see LSFB, so it's why there's like something customized for this launcher. Here when I go to I/O, I can see that there's something which looks like a checkpoint plugin, so let's quickly look at that. Okay, so by just quickly browsing through the code, I can see that this object is responsible for saving a checkpoint, loading a checkpoint, and removing a checkpoint. So also one good practice I found is usually having a look at the base class, right? Like the abstract class which provides the interface. Because when you do, and usually those are quite easy to find out, you can easily understand how how to build on top of it and what the object is actually responsible for, right? So here it's simple because I don't have any code. It just here's my abstraction, right? And here I can see the torch point checkpoint here, which is actually, if I look at it, it's responsible for just checkpointing based on torch utilities, right? And here I can see XLA, and I can see like XLA seems to be related to TPUs, right? Because here I have if TPU available, then import some libraries. So I might not know what's XLA, but I already have an idea that it's related to TPUs, and maybe this specific thing is being used with TPUs. If I wanted to maybe dive a bit into this part, I might actually try to see why it's being used in the code base, right? So here I will just filter within the framework, and here we'll see, okay, it's being imported here. Let's see, here I see the plugin, right? And here I see, okay, yes, it seems to be used inside of the, to be passed as a checkpoint here to the single TPU strategy. Okay, so now I have this connection by just quickly reading the code that the TPU strategy, or like the strategy, seems to be taking like an accelerator, a checkpoint here, and a precision plugin. And I made the connection that this XLA checkpoint here will be used by the TPU strategies, right? So we made already some progress on discovering the code without really diving into how those things are implemented, right? So let's go back here. So yeah, I have done EO, so let's go to precision. Okay, so here in precision it's actually interesting because there is quite a lot of files, and that might seem a little bit confusing. So I think one good thing we can usually do, as I said, is go for the base class, right? And here I can see precision plugin, that's like the namespace of that folder. So I can quickly come here and check what this object is doing, right? So here I see precision plugin, checkpoint hooks. Yeah, so this one seems to have a couple of methods. Yeah, something around backwards, something around, he also handles the closure. So the closure in PyTorch, it's actually the method which is going to perform the forward and the backward, right? So if I know this terminology, I can think already that this object is going to be responsible for this part. And here I see optimizer step, gradients. So I'm really browsing through the code looking for the function names, right? Because that should already give me some very good information on what this thing should be doing, right? And here I'm like, I didn't really look at the code, at what's implemented, but I already know that precision seems to be the component responsible for performing the optimizer step, backward step, and it seems that backward is also specific to the strategy, right? So if we remember how things were built in previously, we had this concept that a strategy was taking a precision plugin, right? So it seems that the strategy, which might be like single process, or yeah, so great question. So we have someone who is asking why is it under plugin rather than core. So I think what we might consider as core outside of the trainer is really the part that the user face, and I think you might be right, like the plugins could have been in core because they're very fundamental objects. But I think in terms of organization, if you were to read that code for the first time, I think when you come here and you look at core, you will see Lightning and you will see data module and maybe optimizer, and maybe some of this code here could be moved out to simplify the things, right? But like what you will expect in core, at least me as a reader, is really what is really like the core part of your framework, right? And here in that case, it would be the Lightning module. So I think those are just decisions that the core team on Lightning made, and I think the framework organization could also be made more readable. So I hope I'm answering your question. It was actually a very good question. Yeah, so that could be something quite a good comment to open as an issue on GitHub, right? Because we could argue that maybe decorators here, or maybe some of this logic here is not core enough and might be moved out, right? So yeah, I think that's actually a very good point. Cool. Okay, so let me go back to precision. So I can see quickly through the names that, okay, there's something around Apex, right? So I might not know what's Apex, so maybe let's quickly Google it together, right? So, okay, Apex, okay, from NVIDIA, that's a framework which has quite a lot of stars. I'm going to quickly check the contributors. So that will tell me how active is the framework. So I can see like activity has gone down, like if I check the past, okay, there's still someone doing some good work here. Yeah, if I wanted, I could even check quickly the commits, right? So just to see what kind of, just looking quickly at the names, like not really look. If something like really grabbed my mind, for example, like grad scalar, I might quickly look at the file which are being worked on, right? So just to see what they are trying to do here. Maybe if I'm really interested by what I see, I will dive deeper, but right now nothing I'm really looking into, right? So I'm still trying to understand like what's Apex, right? So I'm trying to put myself in, in your shoes and how I will go forward onto finding the answers I'm looking for, right? So here I will say Apex seems to be some utilities for mixed precision and distributing in PyTorch. And somehow it seems something that, okay, modifies the modulus and the optimizer, scales the loss, right? And it's been used to apply backward. So first I'm like, okay, that's not the best API, but it means that inside of this Apex AMP, I should find similar logic, right? So here, let's see if it does match. So I should find an AMP initialize. Cool. Okay, so here I can see that this logic, when connected, is actually being done here, right? So initialize. So here, Lightning module, right? So the API matches, and I'm providing the optimizers and also the AMP level. Great. And that seems to be attached to the strategy, right? So now I can already see that the optimizers are owned by the strategy, right? So that's also like some good discovery here, like just quickly browsing through the Apex precision, right? And then I should also find this AMP scale loss, right? Somewhere in this part. Okay, cool. And that happens in the backward, right? So here I can already understand that the role of the precision is to really handle all these nitty details that all those different frameworks like Apex might do, right? So here I can see this Apex AMP framework is the one responsible for like scaling the loss and applying the backward method. And here I can see there is actually other integration, right? So I can see there is deep speed. So are people familiar with the framework deep speed? Anyone wants to comment on? Okay, no, cool. Okay, so awesome. So deep speed is a framework which I think is really exciting, which has been developed by Microsoft, right? And one of the primary, I would say, goal of deep speed was really to scale training, right? So like think about massive models which like definitely doesn't fit on like a single GPU. Like here we are talking about like thousands of GPUs, right? And here we are trying to fit models which are in the orders of billions to trillions to hundreds of trillions parameters. I think deep speed with the latest Infinity, so let's quickly check that, deep speed Infinity paper on archive if people want to check it out, which is Zero Infinity breaking the the GPU memory wall. So they made some crazy thing here with deep speed. So let's quickly look at what they did. Yeah, cool. Okay, so yeah, worth a read here for people who are interested. Definitely some very exciting folks here at Microsoft. And here we can see that they managed to scale to like 32 trillion parameters on 32 NVIDIA DGX2 nodes, right? Which is really impressive. That's really like pushing the edge of what model training can do, right? So it seems that all of that is implemented in DeepSpeed, and definitely a lot of learnings for people who have an interest on state of the art of distributed training here in this framework. So yeah, here I can see DeepSpeed. So now I've learned something new, right? I know there's this framework by Microsoft called DeepSpeed, which actually does quite a lot of cool stuff. Also, I can see somewhere that they might be hiring, so also something quite cool. Yes, and I can see here how they do some stuff. Okay, so here, for example, I can see, like in the same way as we looked at Apex, I can quickly look at the API people are offering, right? Because usually when you do integration, it's really around how those APIs can fit under Lightning and how Lightning can be flexible enough to accommodate all of those, right? And here I can see DeepSpeed as something similar, initialized a couple of things. Then he initialized an init progress group. Actually here, can people convey if they have a good understanding of distributed training, or at least like how DDP works? Can people comment in the chat? If that's of interest, I can quickly explain the... Oh, cool, someone said yes, that's really exciting. Anyone else wants me to dive a little bit into how distributed training works? Okay, so I'm going to make the very short version of it, and okay, cool, awesome. Yeah, okay, so I'm going to do to quickly go through like how DDP works, right? So there's two different ways of doing training. There is one process, multiple device, right, which is usually associated with data parallel, right? But that has a disadvantage that it's quite slow to run. And there is a different way, which is called distributed data parallel, where you have as many processes as you have GPUs, right? So you're running, if you have, let's say, 8 GPUs on your machines, then you will actually run 8 processes. So 8 processes will be running exactly the same code. And the way it works is you take your data. If you have 8 GPUs, you're going to chunk it in 8, and that's the responsibility of an object in PyTorch called the distributed sampler. Every process is going to be given some information. So it's going to be given the number of processes which are running. So we are talking about the word size, how many GPUs are running. So okay, it will be 8. They will know about the global rank. So global rank, if there is only one machine, will be equal to the local rank. If you have multiple machines, it will be actually the global rank across the machines, and the local rank will be the rank in that machine, right? So that's the information, and that gives the position of the process in DDP. The first process, which we call rank 0, in Lightning has a special behavior, because there is some actions you want to perform only once. You don't want to perform it multiple times. So it could be you don't want to log on every GPU. You might want to log only on the first GPU, right? Or you want to checkpoint only once on the first GPU, right? If not, the process are going to, there will be race conditions on some actions, right? This progress group here is going to create a connection between all the processes so they can communicate with each other, right? So when you train with DDP, the distributed sampler is going to enable each ranks to load like a specified chunk of the data. And each process is going to perform one forward with its own version of the model, right? So when you start, you make sure that the seed is the same on all the GPUs, so all the processes have the same seed. And the idea is you are going to try to keep the model in sync every time you go forward, right? So each GPU, each process is going to make a forward, compute the gradients, rely on the progress group to perform an all reduce. So an all reduce is a communication scheme where every GPU asks each other to put its gradients and to perform like a reduction. So it could be like a mean, it could be a sum, but at the end what you get is the same gradients on all the GPUs, and then you can make an optimizer step locally, right? So each GPU is going to forward with maybe with its own batch, compute the gradients, so perform a backward, sync the gradients on all the GPUs, and update the model. So the model is always in sync on all the GPUs, and you go forward like that. And it's why like training gets faster, because the only thing that you need to do really is copy the data to the GPU, perform the forward and the backward, sync the gradients, and keep going, right? Is that clear? Anyone has any questions? Okay, cool. Seems everyone is on board. Cool. Okay, so that's what this init progress group does. And actually, if we try to look for it in Lightning, actually, let's do that quickly. I will see that it's actually done here, right? So I can see here init dist connection. The cluster environment is going to give me the master port and the master address and the master port, because it's a TCP store, right? So all GPU have to be synced? Yes, exactly, right? So if you want to have all the time the same weight on all the GPUs, you need to make sure that the gradients are being synced all the time. And this operation of syncing might take a little bit of time. And there's different way of implementing that, right? So if any of you is curious, you can check about all reduce, and there is a lot of visualization on how the all reduce mechanism works. So let's see if I can quickly show people, right? So here will be an example of how this all reduce algorithm works, for example, where you have multiple workers with different datas, and at the end what you want is all the workers to have exactly the same datas, right? So you will have a communication where all the things communicate, and there is a lot of ways to do that. Some of them which are the more faster. I think one of the most efficient is wing or reduce, where you just communicate with the next one in the line, and you do that multiple times until like all of them actually have the accumulated result on all the GPUs, right? And then you need to do it once more to transmit everything. So I will recommend people to have a look there, because that's a fundamental of distributed training. Cool. So here it's actually where I can see this thing happening, right, in the PyTorch Lightning Codebase. So I can see that the cluster provides the main address and the port. So in PyTorch there is this concept of a TCP store, and that's the object which creates the TCP connection between the GPUs, between the processes, for the gradients to be synchronized, right? So here it's actually was a TCP store has been created, and it is a group which is associated with it. And here I can see I provide the global rank, I provide the word size, right? So here I might have, let's say, 16 GPUs on two machines of 8 GPUs each. The first machine will be indexed from 0 to 7, and the rest from 8 to 15, right? So my global rank on the second rack will be maybe 13. Sharing on distributed training from Aniket. Let's have a quick look. Thanks, Aniket. Yeah, that's that's really cool. Yeah, I mean, I think there is globally a lot of resources. I think distributed training is still misunderstood by a lot of people, but it's not a concept which is too hard. So I think the Lightning team should provide more content on properly explaining that. So here we can see that DeepSpeed is using a different mechanism for initializing. Also, when they make a forward, they seems to do it with a model engine, which is created here when they do DeepSpeed initialized, right? So here's my NN module. Here is a DeepSpeed engine NN module, and that's the one we should be used for the forward, right? So that might seem a bit weird, but one thing to know is DeepSpeed actually goes beyond DDP, right? Like DeepSpeed actually supports sharding, which is you take the parameter and you cut them, and then you give this responsibility of the chunk on this GPU. So it's actually more complex to handle, and DeepSpeed does some crazy magic internally. If people are interested, it's a great framework to learn from. They also do backward, right? So they also need to do the loss, and they also handle the step, right? So here I can see already that DeepSpeed has a very uncommon API, right? And I should be able to find some of that inside of Lightning, right? So if I check here, I can see, okay, so the DeepSpeed engine is actually under the trainer.model, right? So I can access it this way. And here I can see in the backward hook of the DeepSpeed Precision plugin, I receive the Lightning module, the loss, and the DeepSpeed.backward is being called, right? So that seems to be matching what I can see here, right? Let's see if I can recognize more things. Here I have the run backward. Okay, that's fair. Optimize the step. So the closure is being executed. So as I said, closure is what does the forward and the backward. Once the closure has been executed, here I can see DeepSpeed step, which seems to be matching what I can see here. And some logic here for clip gradients. Can actually I see that DeepSpeed doesn't support, like we don't need to override it, like DeepSpeed does it already, right? So, okay, cool. So I've got a little bit of knowledge around DeepSpeed. So maybe I can keep going. So here I can see FSDP, IPUs. So if people don't know what's IPU, that's some hardware which is being developed by Graphcore. So they are called actually intelligence processing units. So yeah, if people want to learn more about it, you can always check them out. So let's continue. Mixed precision, right? So that's the idea that you can have. Can you explain the idea behind the closure for optimize the step? Yes, so the closure, so let's actually Lightning as an abstraction for the closure, right? So usually when you don't know something, when those terms comes out, like just search them through the code base, right? So here we have an abstract closure, which implements, which basically combines three elements, right? The training step, which takes a batch and computes the loss, the backward and the regret, right? And here if I don't, like without looking too much in the details, I can already see that I can create a closure which is going to do something, get my optimizer and pass it to my optimizer.step, and that will actually perform a step on my models, right? So if we think about what's happening, training step creates a loss. From the loss we call backward. Now the parameters of the model on a gradient, and then the optimizer step can update the weights based on the gradients, right? So here if I look at the call method, you execute the closure, and here I can really see quickly what it does. So here I can see I get the step output, and then the step output actually owns the closure, and that's being called the pass to the backward function, right? So without going too much in the details, I can already see there is, and somehow there is an abstraction in Lightning which takes care of enabling that, right? Cool. I hope I answered your question. I didn't want to go too much in the details, but I think when you are looking for something, you can just look at like the thing, right? When there is a terminology you don't fully understand, you can just quickly look at those, right? And here there might be like answers in the code base that you might come across. Okay, cool. So let's keep going. Actually, I wanted to run some code, so let's see how much time is left. Okay, so I still have 15 minutes, so I'm going to accelerate a little bit more. Actually taking slightly more time than I thought. Okay, so I was in the precision, so mixed precision, native IMP, I can see sharded native, so yeah, this idea that model can be sharded. Seems also there's something around TPUs here, so TPUs have maybe their own way of doing things, right? So I've gone through these ones, and I can check profiling. As I shared before, I think it's always good to look at the base, right, when it's clearly explained. So here I can see an abstract profiler. It has a start, a stop, a summary, setup, and teardown method, so very straightforward. I can see there is a base profiler, which seems to be some stuff. Also, one thing which I found to be quite nice is like usually when people implement a framework, it's also you usually get, especially in Python, a one-to-one mapping between the file name or the folder name to some test, right? So what I will usually do is check the test to try to understand how those objects are being used, right? So here I will see here's my simple profiler, and somehow it seems to describe some stuff, right? So it seems that there's actually an argument on the trainer where I can create my profiler, right? So here will be, okay, if maybe one day I want to create my own profiler, I can look into the test and see how they do it. And here, going back, I can see they have actually 4 types of profiler, right? Because there's 4 files. So they have, so let's go for simple, right? So, I mean, I'm looking at Lightning for the first time, right? So let's go for the simple one first, right? So here I have simple profiler. Okay, I guess simple here means, so let's maybe quickly look what it does. This profiler simply records the duration of action in second and report the mean duration. Okay, so I think that's something which should be fairly simple to implement, right? Where I get a start time, and every time an action is being started, then I'm recording the time, and then when it stops, I get the end time, and I compute the duration, and I say that's my duration, right? That seems really straightforward. And then I guess there is this summary method, which is going to go through all those different things and kind of explain me how this thing works, right? Maybe also one thing I could do, instead of searching here, I could also search here, right? So usually Lightning provide documentation with, I mean, there is a documentation with all objects, right? So what I could do here is say, instead of, I mean, I could go here 100% and search for everything, right? But I usually just like to go from here where I was to here, right? So just to do a bit of filtering, I just filter the docs, and here I can say, oh, here's a profiling, here's how to use it, here is a report which is being generated, and here's how it looks, right? So if I was to go back to, let's say, the class I was, actually let's keep that this way, and let's go back to, let's close that, let's go back to Lightning. I was in profiler, I was in simple. Now I can, if I check a bit the code, I can see that it seems that this thing here seems actually the method responsible for generating what I had in the doc, right? So what I was seeing right here. So that will be the method to be responsible of that. If I wanted to dive more, then all the logic will be there, right? So let's quickly keep going through the exploration of the code base. Any questions so far? Any things that people might want me to answer as I go, as I keep going? Any questions? Okay, so here I have the advanced one. So okay, this one is using CF profiler. Cool, so a different way of doing profiling, which I guess is more in-depth, I guess, like really function calls, right? It seems to be very simple in terms of implementations, right? It's just you have a C profile on start, and you just disable it on end, so very simple, right? And here there is the PyTorch profiler. So here I can actually see that there is more meat to that file, right? So that will take more logic to run into, but I guess here I can see, oh, it's using the autograd profiler. So if I've never heard of that, I can quickly try to check it out. I mean, I know that object is called Kineto, so maybe that's something I could also grab here in the code base, or maybe even from the top. Yes, okay, here I can see if Kineto available, so that also give me a name, like a in that there is something around it. So here I'm on the PyTorch Kineto profiler page, and I can get some details of it about what they do. They're not too verbose actually about what they do. I wish they were. Okay, let's see. Okay, here is actually the API, right, which is with Torch Profiler profile, then you have some code to profile, and then you can actually get from the profiler a table of all the recorded actions. So here in theory, I think I should be able to find that in that class, right, just to sanity check. Yes, okay, I can see that, yeah, in fact there is Torch Profiler, and then all this code is basically wrapping all the PyTorch profiler profile object into like a very comprehensive class. Okay, let's keep going. So strategies. So strategies used to be plugins, but we thought that strategies were a better match to express the diversity of things which are implemented here. And here we can actually see a couple of things, right? So here in strategies, I can see launchers. So I can see there's actually several ways of launching things, right? I can see things can either be spawned, right? So you create processes with mp.spawn, or they can be created as sub-processes, right? So that give me already a hint that as I know, as DDP requires multiple processes to work, now there is actually two different ways that those can be launched. And if I was to look here in the code, I should actually find a sub-process popen, which is what I will expect. What I will expect, right? And here, XLA spawn. From my reading of the code, I remember that XLA seemed to be attached to the TPU concept, right? Because I can see XLA here. It seems that those are linked. So here I am, okay, so now there is a different way to actually spawn or create processes with the spawn method between GPUs or CPUs and TPUs, right? So this is something very specific for TPUs that needs to be done, and I can actually see already that they rely on XPM, and that Torch XLA, which I don't necessarily know what it is, but it provides its own multiprocessing library, right? So if I check it out, and quickly check what it is. Torch XLA enable PyTorch to run on enabling PyTorch on Google TPUs, right? So doesn't have much does. Let's see how actively. Okay, we can see that somehow it's dying out a bit, which is not great. And Jack is the primary developer of the framework, or at least of the support of PyTorch on TPUs, right? Cool, so launchers, and here I can see there's a lot of files, right? So I guess those are all the different strategies which exist in Lightning. So I can see there's one which is called Bagua, never heard of it, what is it, how do I use it? As always, you Google it, you find it on GitHub. Bagua, what does it do? It's deploying training acceleration frameworks. What does it provide? It provides some advanced training algorithm. So I think that's like more advanced or reduced mechanism. I can see decentralized synchronous communication, some cool stuff here. Also, it seems they have their own TCP communication acceleration. And if I'm actually quite curious, I will see that it's written in Rust, which I think is really interesting, really exciting. They also have some auto-tuners, some load balanced data loader. So yeah, I think if you don't know, I think that's a framework which is worth to look into. And here when I look at the performance, I can see that if I was to compare pure DDP, which is here in green, Bagua synchronous seems to provide actually a very decent speed up. I can see, yeah, at least 2 to 3 times faster. So now I'm like, cool. There is this thing in Lightning out of the box, right, which is Baga. So maybe I might want to know how to use it, right? I think that's like my next step. So here I will check the docs, find the class, find Bagua. So here, okay, cool. Here I find it already, right? So Bagua, strategy called Bagua, but maybe I can get more information here. So let's quickly go through. Okay, so here I can see already how to use it, right? So I just need to do trainer strategy equal Bagua, and now I can basically use a Bagua library if this one was actually installed. So I think they have here an explanation on how this thing should be installed somewhere. But yeah, if it's installed, then it means it can be used very easily with Lightning, right? So yeah, I didn't know what was Bagua, let's say, before, but now by just looking at the file name, I already have an idea of what this thing does. DDP spawn, DDP, DDP2, deep speed, DP, fully sharded, override, IPU, parallel, sharded spawn, sharded single device, single TPU. So definitely I can already see that Lightning supports a ton of way of doing training. And I think as a user of Lightning, you need to be, I think you need to try them out, because they provide, depending on your model, you can get some good performance gains. So yeah, worth to be curious here. A lot of very interesting thing. And then there's a trainer. So the trainer is actually quite big. There's a lot of code here. It seems that the trainer is actually coming from here, right? And when I check this file, it seems to be, yeah, definitely a massive file, right? Here we are talking about 2,500 lines of code. So I'm definitely not going to read that code. But what I will usually do, and yeah, I think I'm actually close to. I didn't have actually time to run through the example, so I think there will be a second session to this talk. But what I wanted to share is what I will usually do once I've quickly browsed the code base. And here I won't really in depth for you to grasp how I usually do the things, right? But the next step to me will be really to create some dummy example, right? So I can see that Lightning has this concept of a borrowing module, which is like the most lightweight NN module you can imagine, with the most lightweight data. So the data actually created at start, right? And here there's a trainer, there's a fit method, the validate, the test, and predict, right? So what I will usually do is I will start from the most minimum examples that the documentation or the README provides, right? So here I have the Lightning README, which is really something like that, right? Like a simple NN module, a simple trainer. And then I will just try to look at the init methods, right? Because those usually do quite a lot, right? So here I will check, okay, here's my Lightning modules, couple of mixins, a couple of arguments, not much here, right? And then I will go back to my demo and I will check the trainer. So I think here also a good way to understand that once we have gone through like all the namespace, I think a good way to go forward is to look at the primary interface users are dealing with, right? So I think the primary one is really the trainer. And I think having an idea of the objects which are passed as argument and the type of those arguments usually provide a lot of values, right? So here you will check loggers and you will see, oh, there's a Lightning logger base, checkpoint callbacks, enable checkpointing, right? And going through all of them and checking out the doc string already give you a lot of information about Lightning internals. And I remember myself like 1 year and a half ago, that was actually the first thing I did. I took the time and I read all of those arguments, exactly what they were doing. I went through the base class and tried to quickly understand what they do, because that's the entry point of everything, right? Like once the model is created, the trainer orchestrates everything else, right? So really understanding what all those argument does already make me extremely powerful. I already know what Lightning has to offer, at least at the trainer level, right? And then what I wanted to show, but I think I will keep it for the next session, so if people are excited about it, we can definitely do that. But what I wanted to show is how I will actually go forward. So here I have done like a static, let's say, analysis of the code base, but the next step will actually to run the code, right? And what I found to be quite good is to run in debug mode, right? So here, for example, what I will do is I will check where the code goes, because I think when is the second session? I don't know, hopefully maybe next week, maybe the week after, I'm not 100% sure, but if that's in people's interest, I can definitely do that. yeah, and what I wanted to show, but we'll keep it for next week, is what I will usually do is track where the code goes, right? Because when I started Lightning, first it wasn't as good as it is now. I think Lightning has improved immensely since the last time, but I think the thing which is really key to me was understanding where the code goes, right? And I think as a user, and if you want to grow as a software developer, you need to be very curious about the tools you are using, right? Like, if you understand how they work, you will be faster at doing your job, because you will find the ways and creative ways to utilize them for the task you are given, right? So here what I did was, which was actually very confusing to me the first time when I went that first thing, right? Because here I go through the trainer and somehow it gets inside of this class, and I was, oh, okay, so now there's a decorator, right? Which is being used, right, to decorate the init method of the trainer, right? So I was actually quite confused when I went this one first, right? And here I can see what they do is they're actually parsing the environment variables. So you can inject your arguments inside of the trainer directly from the command line, right? So you could say pl.trainer, I don't know, like max epochs, right? Equal 1, and then python train.py, and this method here will basically catch them up and inject them as cargs, right? So yeah, so that was something quite interesting when I started. And here you will continue and you will go through the code, right, like running line by line, trying to understand what the code does for this very tiny example, right? And usually you will try to remove as much features as you can. So you will keep it as contained as possible. And Lightning has this quite amazing flag, which is fast dev run, right? And if you check what this thing does, you just run only one batch of train val test, and here you can already see there is a typo, right? Like predict is not here. So if anyone wants to make like a PR to add predict here, be my guest. But here, and here you can see that if you were to run this code very quickly, up, it just goes through everything. So I had actually a couple of breakpoints which I added in the code. Don't need all of them anymore. But yeah, so that was, I guess that will be for next time. We will go through this very simple demo, track the code, see where we end up with, and if people have questions, if people have interest, please raise them. Once I go through the next demo, I will be happy to go through some specific part of the code base if people are interested. Anyone has any questions? Anything they would like to ask before I stop this session? For a metric dive in, yeah, metric. So are you, just to be sure, are you referring to Torch metric on GitHub? Is that correct? Cool, awesome. So here's my advice to you, right? So here metric is I will do basically the same. Like if you wanted to better understand metric, I will do exactly the same as what I did today, right? And I think the best way to usually start is to look for the core, because the core shows you the abstraction on which everything else is being built out, right? So if you really to understand metric deeply, I think the best thing is to look at, okay, here I know where I'm going, right? So let's take it one step back if I was one of you, right? So get on Torch metric, and for people who don't know Torch metric is a framework which started out of Lightning and become its own, and it's really metrics implemented for distributed scalable PyTorch application, and I think it implements right now, like 50 or 60 plus PyTorch metrics out of the box that people can implement very easily, and they can compute the metrics for each batch, but also across an epoch, and that works in a distributed way without even you having to implement it, right? So if you wanted to understand how this thing is being implemented, you will go here on torch metric, and you will look for like the base class, right? So let's say I don't know what I'm looking for. I will check, let's say, classification, right? Accuracy. I think this one will be the first one I will look at, right? So let's look quickly at the API of accuracy. It seems accuracy actually is relying on true positives, false positive for its implementation. But at the core, I can see that it implements 3 methods: init, update, and compute, right? And I can see also that if I was to follow this one, I can see the base class is StatScore, and the base class of StatScore is metric, and metric will actually be the base of the entire framework, right? So if someone was of interest to learn how metric is implemented, I think that would be the best place to start. It's not too complex, really. I think it's a great place to start understanding the concept of a metric and how distributed works. But really at the core, there is a place where you register the state, there is a place where you perform a forward, a place where you sync the metrics. Right, so here I can see some logic to sync the metrics, and then the update and compute the user have to implement. And then also the function you will be looking for are those wrap update and wrap methods, which are responsible to do some extra logic around those methods. Cool. Okay, so thank you everyone for joining the call today. I hope it was helpful. What I found to be very useful for me in the past was to always read a lot of code, because there's a lot of very smart people out there which have done very similar work to mine, and if I can learn from them, then I can be better at my job, right? So and if any of you is also interested in making contribution to PyTorch Lightning, I think that would be very exciting for the project. Okay, thanks everyone. Have a great day and a great weekend, and yeah, looking forward for session 2. Bye everyone.